Let's look at asymptotes now. It's a very interesting subject for many of the high school students, where they wish to know how to get this topic in their mind clear. It's always been my challenge to put this topic to my students. First of all, asymptotes exist typically on reciprocal functions. So I need to typically have a numerator f of x and g of x. So f of x upon g of x. So if I say this, I will have a numerator, a denominator. Let me start with a simple example. 1 by x plus 1. You explore the possibility of making denominator 0. Asymptotes is all about, what is asymptote? Asymptote is when denominator is 0, when x tends to minus 1, or equal to minus 1, not tends to, I can say equals to minus 1, y tends to infinity. 1 by minus 1 plus 1 is 0. So when a line x equals minus 1 can make the curve y tending to infinity, implies x equals minus 1 is obviously a vertical line. You must be knowing in a graph sheet, x equals minus 1 is a vertical line. So on this line, no curve touches. The curve won't touch. Y becoming infinity. Tends to. On this line, the curve won't touch. Asymptotic. It's asymptotic behavior. So this is called vertical asymptote. Now let's take more examples. As you had asked me via examples to teach asymptotes, I'm going to take typical examples. Take this time x plus 1 by x minus 2. I'll take another example, x by 1 minus x square. Another example, x square minus 1 by x square minus 4. I've taken 3 varieties of examples. In this case, a linear function is f of x, a linear function is g of x. In this case, I've taken a linear function f of x and a quadratic function g of x. In this case, I've taken a quadratic function g of x and a quadratic function f of x, both. Let's look at this. Now, the challenge is, before I go to these 3 functions, I missed to say, this is the vertical asymptote I talked about. What about horizontal asymptote? What you should do, look at look at the power of x. No? Yeah, look at the power of x, which is here 1. Please try to divide numerator and denominator by highest power of x. Here the highest power or lowest power, whatever it is, it's only 1. So I'm going to explore dividing by x in numerator, x plus 1 by x, by which the value won't change. My existing function won't change because I'm dividing the same term in numerator denominator.
So if it was your x square plus
I'm going to come to that. That's next. It's all here. I'm just waiting this to finish. You'll get some knowledge on this basis. X by x is 1, 1 by x. Now what is vertical asymptote? It's all about as x tends to infinity. Horizontal asymptote is all about, I'm discussing horizontal asymptote now. I've discussed already vertical asymptote. This is all about the horizontal line being where the curve won't touch, not vertical line. So I need to spread the x values infinitely right side and minus infinitely left side. If I do that, I'm going to tend this x tends to 0. What will happen to y? 1 by infinity upon 1 plus 1 by infinity. We all know a large infinite number is in denominator, 1 by that will become 0. So it will be 0 by 1 plus 0, answer is 0. So y equals 0. So my horizontal asymptote is y equals 0, which means geometrically speaking the curve won't curve won't touch x-axis. It will tend to go closer and closer to x-axis, but it won't touch. So this is the way you understand the basics of asymptotes. Understanding in
So your 0 you put instead of infinity.
I put tends to infinity.
Okay.
If I put tends to infinity, 1 by infinity
0
upon 1 plus 1 by infinity.
Okay.
1 by infinity is 0, 1 by infinity is 0, 0 by 1 plus 0 is 0.
Okay. Correct.
Now let's go and discuss a little more dynamic examples. Now we have y equals x plus 1 upon x minus 2. I told you first initiate the process where you say explore denominator first. My g of x is x minus 2. My f of x is x plus 1. I told you put denominator equals 0 or g of x equals 0. Initiate this process. Why am I doing this? Because by initiating the denominator equals 0,
Vertical.
I can see the behavior of y, which is going to be anything upon 0 is infinity. Vertical asymptote is all about try to take the vertical line to infinite distance and see what happens actually. So by doing that, I want to see the nature of x. At x equals 2, y tends to infinity. Don't say y equals infinity. There's nothing called equals infinity. At x tends to 2, because 2 minus 2 is 0. Anything upon 2 plus 1 3, 2 minus 2 0, 3 by 0 infinity. So at x equals 2, y tends to infinity. So if I have a graph sheet, my 1 2, this will be somewhere here. The curve won't touch. It infinitely go up, but it won't touch the curve, the line y equals 2. I'm sorry, x equals 2. Apologies. Now let's come to this is the vertical asymptote I finished. Let's come to horizontal asymptote, which is all about allowing x to go spreading horizontally. You allow x to spread infinitely right hand side, minus infinitely left hand side. For that, I first ensure that I divide by the highest power of x in numerator and denominator, which is raised to 1. So I'm going to divide x plus 1 by x upon x minus 2 by x. What happens here? 1 plus 1 by x, y equals 1 plus 1 by x upon 1 minus 2 by x. When you tend x tends to infinity, 1 by infinity is 0, 2 by infinity is 0, so it will become 1 plus 0, 1 minus 0, which becomes 1. So my horizontal asymptote is going to be a line called y equals 1. So when x tends to infinity, y equals 1. So I have defined for you y equals 1 as horizontal asymptote and x equals 2 as vertical asymptote. To summarize, for vertical asymptote we initiate the process by keeping denominator equals 0, which is the kick start for the thought process. For the vertical horizontal asymptote, we initiate the process by dividing the highest power of x in nr and dr, that is numerator and denominator. Let's go to the next example, which is here we are finding a different approach. We find here x by 1 minus x square. So let's start with the vertical asymptote.
1 minus x equal to 0.
1 by
1 minus x equal to 0.
So if you start this process, put 1 minus x square equals 0. If you put 1 minus x square equals 0, the x square possibilities can be either x equals 1, x equals 1 or x equals minus 1. Knowing this, I am going to show this in my graphical calculator. I've drawn this actually y equals x by 1 minus x square. So if I draw this, you will see that yeah, first define x equals 1, x equals minus 1 are the. So if you actually put this value, you will get 1 upon 0 or minus 1 upon 0, which is infinity. Let's see how it works. See this. Now I'll zoom this across and show it to you. You will see, I'll further zoom it. You will see this 1, x equals 1 is this line, and x equals minus 1 is this line. I can even show further. Draw this x equals 1 and show it asymptote actually in the graph. I'm going and plotting x equals 1, x equals minus 1 in the calculator and drawing and showing it. You may see a red line passing through the curve. The blue color is the curve. The red line is the asymptote of x equals 1, and the green line is the asymptote x equals minus 1, and you would observe that the curve does not touch these lines. So this is the way you can assume, you can visualize the asymptote through a graphical display calculator. Now if I further zoom out, I can see something more. You also find that there is also an horizontal asymptote behavior. How to find this? How do you go about finding the horizontal behavior? Now, if what did I say a few minutes back is highest power of x to divide in numerator denominator for horizontal asymptote. If you see in the calculator, you see a behavior where if I go and substitute, I want to know what happens when y value when yx is 0. Let's try this first. Y is 0. Now I want to find a large value of, let's put other way, I want to find in the graph when x calculate when y is 0. 0. Now if you further move the right side calculate, if you see another point, it won't touch. I'm right scrolling and left scrolling. The only point it goes through is this. Now I want to do this is what I did in the graphical calculator, but I want to go horizontal asymptote by our conventional method of dividing by x square. Highest power of x is 2. So x by x square upon
1 minus x square.
1 by x square minus 1.
There will be 1 minus x square upon x.
Gets cancelled. 1 by x upon 1 by x square minus 1. As x tends to infinity, what will happen? 1 by infinity is 0. 1 by infinity square is 0 minus 1. So answer is 0. You see y equals 0. This curve y equals 0 is the horizontal line. Y equals 0 is the horizontal line. If you see